Hello, this is not your chem tutor, and in this video, I will teach you how to find the empirical formula from combustion analysis. Specifically, we will focus on compounds containing carbon, hydrogen, and oxygen because this type of compound is what you usually encounter in general chemistry exams and problem sets. Okay, so before you continue this video, make sure you're already familiar on the basics of finding the empirical formula. If not, then don't worry, I made a separate video and you can check that video using the link in the description box. So for this video, we will only answer one example and we will answer this example step by step, detailed step by step. All right? Okay, so for example 1, a 2.50 gram compound containing carbon, hydrogen, and oxygen was combusted, yielding 5.49 grams of carbon dioxide and 3.00 grams of water. What is the empirical formula of the compound? So the molar masses are also provided in the question. So let's answer this step by step as what I've told you. So step number 1 is you need to solve the moles of carbon from carbon dioxide. So in the problem, we are given 5.49 grams of carbon dioxide. So we will be using mole concept to solve for the moles of carbon. So if you're still not familiar with mole concept, I also made a separate video. You can also check the link in the description box. So according to the problem, the molar mass of carbon dioxide is 44.01 grams per mole. So that means 1 mole of carbon dioxide is equivalent to 44.01 grams of carbon dioxide. So you know that the grams of carbon dioxide will cancel out. Now we have moles of carbon dioxide, but what we want is moles of carbon. And just by looking at the chemical formula of carbon dioxide, CO2, it means that 1 mole of carbon dioxide contains 1 mole of carbon. So the moles of carbon dioxide cancels out. Now we have moles of carbon. If you solve this in your calculator, you will get approximately 0.125 moles of carbon. So that's for step 1. Let's move on to step number 2. Solve for the moles of hydrogen from water. So in the problem, we are given 3.00 grams of water. And according to the problem, the molar mass of water is 18.016 grams per mole. By the way, if the molar masses are not given in the problem, you can simply solve them if you have your periodic table with you. Okay, so I just provided the molar mass so we will be quicker in our calculations. So again, the molar mass, 1 mole of water is equivalent to 18.016 grams of water. So the grams of water cancels out. Now we have moles of water. But what we want is moles of hydrogen. So just by looking at the chemical formula of water, H2O, that means 1 mole of water has 2 moles of hydrogen. So the moles of H2O cancels out. Now we are left with moles of hydrogen. And if you solve this in your calculator, you will get approximately 0.333 moles of hydrogen. So again, that's for step 2. I hope you're still following. Now let's move on to step number 3. For step number 3, we need to solve the mass of carbon. How do we get the mass of carbon? Remember, in step number 1, we got the moles of carbon, 0.125 moles. And in the problem, we are given the molar mass of carbon, which is 12.01 grams per mole. That means 1 mole of carbon is equivalent to 12.01 grams of carbon. So, the moles of carbon will cancel, and this gives us the mass of carbon or the grams of carbon. And if you solve this, this is approximately 1.50 grams of carbon. So that's for step 3. Let's move on to step number 4. Solve for the mass of hydrogen. So if you remember in step number 2, we got the moles of hydrogen, which is 0.333 moles. And in the problem, we are given the molar mass of hydrogen, which is 1.008 grams per mole. So again, we do mole concept. That means 1 mole of hydrogen is equivalent to 1.008 grams of hydrogen. So the moles of hydrogen cancels out, and this gives us grams of hydrogen. And if you solve this in your calculator, you will get approximately 0.34 grams of hydrogen. So that's for step number 4. Now let's move on to step number 5. Again, I hope you're still following. In step number 5, it says here, solve for the mass of oxygen. So how do we solve the mass of oxygen? Remember, if we go back to our initial problem, it says here that we are given 2.50 grams of the compound. So 2.50 grams. So we start with 2.50 grams of compound. And according to the problem again, the compound only contains 3 elements: carbon, hydrogen, and oxygen. And from step number 3, we got the grams of carbon. So what we can do is we can subtract 1.50 grams because this is the mass of carbon. So 2.50 grams again is the mass of the compound. 1.50 grams is the mass of carbon. And if you subtract again the mass of hydrogen, 0.34 grams, what is left is the mass of oxygen. Again, the mass of oxygen, you can solve it by subtracting the mass of carbon and the mass of hydrogen from the mass of the compound. So 2.50 minus 1.50 minus 0.34, you will get 0.66 grams of oxygen. Okay, so I hope you were following. So now that we have the mass of oxygen, we can now solve for the moles of oxygen. So again, we got 0.66 grams of oxygen. And in the problem, we are given the molar mass of oxygen, which is 0.16 grams per mole. So that means 1 mole of oxygen is equivalent to 16 grams of oxygen. So the grams of oxygen cancels out. So we are left with moles of oxygen. And if you solve this in your calculator, you will get 0.041 moles of oxygen. So that's for step number 6. Now we have 2 steps left to solve this problem. So for step number 7, it says here, put the moles as the subscripts of the elements. So let's just go back a little. In step number 1, we solved for the moles of carbon, 0.125 moles. In step number 2, we solved for the moles of hydrogen, 0.0333 moles. And in step number 6, we solved the moles of oxygen, 0.041 moles. In step number 7, it says here that the moles will be put as subscripts of the elements. So for carbon, what we got from step 1 is 0.125 moles. For hydrogen, in step 2, we got 0.333 moles. In step 6, for oxygen, we got 0.041 moles. So that's for step number 7. You put the moles as the subscript of the element. And for step number 8, divide all the subscripts by the smallest one. So among the 3 subscripts, which one is the smallest? It's obviously 0.041. So according to step number 8, you will divide all the subscripts by the smallest one. So you do 0.125 divided by 0.041, 0.333 divided by 0.041, and you do 0.041 divided by 0.041. So for carbon, 0.125 divided by 0.041. If you round that to whole number, that's 3. For hydrogen, 0.333 divided by 0.041. If you round that to the nearest whole number, that's 8. And for oxygen, 0.041 divided by 0.041, that's obviously 1. So C3H8O1. In chemistry, we know that if the subscript is 1, we omit it or we drop the 1. So it simply becomes C3H8O. So the answer to this question is C3H8O. Again, we have 8 steps. I know it's too long, but if you just follow step by step and you apply this in all problems involving combustion analysis, then for sure you will get the empirical formula. Okay? Thank you so much for listening.